So today we're looking at the determinant and inverse of matrices. So we need to learn how to do the inverse of a matrix because we'll need it in solving other problems. So first of all, we're going to look at the determinant of a matrix. If you look, and we're only ever going to manually do a 2 by 2 matrix. So if you look here, this is a 2 by 2. We don't ask you to manually do any other one. You would just do it on your calculator. So if we are finding the determinant of a 2 by 2 matrix, what the determinant actually is you get this number, whatever number's there, and you times it by this one, so that spot. So the A position times by that D position. Then you minus that, minus from it, this one times this one. So you can see here, there's that rule that I just did. So if you have a look at the example here, so they did 2 times 5 there, and then they minus 3 times 3. So that would be 10 minus 9, which gives 1. So the determinant of this matrix is 1. If you're on your calculator, all you have to do is type DET, the letters, and then open a curly bracket and then put your matrix and press enter, and it should do it. I'll screen dump some examples on there later. So if we go to do this matrix H here for the example, so we're going to, if we were finding the determinant of H, we would say that is equal to 2 times 3 minus 4 times 2. And so then you've got 6 minus 8 equals negative 2. So you can have a negative determinant and you can have a positive one. The thing that why do we learn how to do the determinant? Because when the determinant equals 0, that can tell us certain things about certain problems. So let's keep going. Now, let's move on to the inverse of a matrix. So if you look up here, the inverse of a matrix. So what is an inverse? See how we can write the inverse of a number or something with the power of -1. So if I said 3 to the power of -1, that's like saying 1 over 3. Yeah, it's the same thing. So if I have matrix A to the power of -1, that's like saying essentially 1 over matrix A. Now, if you have a look, is that the same? If you times something by a third, is that like, say, the same as dividing by 3? Would you agree? Yeah? Same as dividing by 3? Yeah? So if you look, if we've got the inverse, if we times something by the inverse, it's like dividing by that matrix, isn't it? Yeah? So in matrices, we can't essentially divide. So in matrices, when we need to divide to solve a problem, we need to times by the inverse. So if you know that fact, it's going to help you because you'll know how to solve a problem. You'll go, oh, we would normally divide there. Well, if you have to divide, you're going to times by the inverse. So that is why we're learning how to find the inverse. And once again, you only have to manually find one of a 2 by 2. So if you have a look, this is how you find the inverse manually. Now, what can you see? Here's what the matrix normally looks like. Can you see they've swapped the D and the A? So they'll swap those two numbers and then they will make these numbers negative. All right? And then once you've done that, you're going to times by 1 over and then you'll do AD times BC. If you notice, that is actually the determinant written there. So we can see that we're going to times it by the 1 over the determinant. So if the determinant ends up being 0, if you have 1, can you have 1 divided by 0? No. So can you see if the determinant equals 0, you cannot find the inverse, can you? there'll be no inverse. So that tells us a lot about a problem, that we might not be able to find it. So there's a little, what we call it. So if the determinant equals 0, it's called, the matrix is called singular, and there's no unique solution. Because what happens is we're going to solve simultaneous equations. So if you remember, if you have two lines that, crossing on a graph, when you solve simultaneously, you generally are finding that unique answer where they cross, yeah? So that unique answer, that's the time when both of those lines equal the same thing when you put the x in. So that's a unique answer. If you can't solve that, so if you see, and this is what happens when we can't solve that, it's probably our lines are doing this, or our lines might even actually be the same line, just, written in a different way. So this scenario here, these two scenarios here, that happens when the determinant equals 0. Okay, so it's singular. There, you never get that unique answer. Up here, this is when the determinant is anything but 0. So you might use that to answer. So let's go find the determinant, or the inverse, of a matrix manually to see if we can do it. So we've got matrix A here. So first we're going to find the determinant, because we use that. So we go 2 times 3, there, minus 4 times 2, and we end up with -2. So you can see when up here the rule said 1 over the determinant, so we've put that there. So there's your determinant. Now we got told to swap these two numbers, so you can see those, and we've got told to make these ones negative, and we've done that. So then you would just times out. So if you do 3 times -1/2, you get -1.5, and you can do that on your calculator if you're not confident, and then you get 2, 1, and 1. Okay, so that would be finding the inverse manually. So let's go just to talk about our on our calculator, just quickly. So as I said, they've defined A. You don't need to. Just type DET if you're trying to find the determinant. Put a curly bracket, type in your matrix, and then press enter. If you're trying to get the inverse on your calculator without having to do it manually, you just type in your matrix, whatever it is, blah, 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 and then just raise it to the power of -1, and then press enter, and that will give you the inverse matrix manually. All right, so we're going to leave that there, and I'm going to go on to the next 12B. So that's sort of all together.